Hello.
Hello.
This is Tech Days Online, but we're usually doing Webpack Wednesdays.
Yeah.
We're about to take over. Cue the credits. So, what are we going to be talking about today?
Are we going to be talking about machine learning today?
I've been doing a lot more machine learning.
Have you?
We talked about
You've been
this
learning about machine learning.
We talked about this a few months ago, and we've been on the road doing our web days.
Yeah.
And we do have a machine learning track in there.
We do, yeah.
But subsequently, since we've stopped doing them, and I've not seen you in about a month or two,
Yeah.
I've been doing a talk which has a big segment in sort of machine learning. So I've been kind of I have been polishing my machine learning.
Knowledge.
Knowledge, yeah. Okay.
Can you polish knowledge? Is that a thing? I don't know.
Well,
sharpening is probably the thing that you were going for.
That's where I've been going wrong.
Yeah.
All these
You've been polishing it rather than sharpening it.
But now I have some machine learning knowledge, so this would be.
That's dangerous. That sounds like a dangerous
just
thing.
Just a little bit of machine learning knowledge.
Just enough machine learning knowledge to machine learning is quite powerful. So if you've got a little bit of machine learning knowledge, and your name's BB, then.
Well, also, I worked a little bit on one of the projects that you wrote, the How Happy stuff.
Yeah,
and
we're going to take a look at that in a bit.
I built a cross-platform version of that.
Nice.
Yeah, it's not nice actually. It needs some work. But
so does my one actually.
But yeah, so and I've been doing quite a lot of stuff with some of the artificial intelligence Lewis APIs as well.
Cool.
So let's dig in then.
Yeah. So we're going to sort of look at machine learning just generally because it's one of those areas that I think. It seems scary.
Mm-hmm.
Like if you're just a regular dev like we are, it seems like the idea of machine learning seems like a scary thing because it's like algorithms and maths and like scary things like that.
Yeah.
When we just want to call an API and get some stuff back, and so what we're going to look at is like why machine learning is important. So why it's important to kind of really understand what goes on with machine learning.
Yeah.
Because it's used everywhere. You know, it's kind of in any bit of software that you use, any website, any app these days, it's probably going to have some sort of machine learning in it. Yeah. And it's all about big data. You know, you have to have the data to put into the machine learning processes in order to understand what's going on. So we're going to look at machine learning generally a little bit, and then we're going to look at cognitive services, which is like the kind of machine learning for muggles. Yeah,
and it used to be cognitive services used to be Project Oxford.
Yeah,
now
that's right.
Called, a much better name actually.
It is,
cognitive. It makes it sound more serious.
It does, yeah. And you don't have that weird thing about why is it called Project Oxford when it was made in Cambridge.
Which we still don't know the answer to. No one has told us. No. And I've looked into it.
I've asked people and nobody knows.
Nobody knows. There's one guy.
Somebody knows, somebody knows the answer.
I wonder, I hope, maybe it was just like an American thing, like there's an American project manager. And he was like, those guys in Oxford.
It's all the same place.
Those guys in Oxford.
Little old England.
And they were like, why is it called Project Oxford? I have no idea. And just someone got confused between Oxford and Cambridge. I'd love that to be true.
No, that would be cool.
Maybe that could be the reason. Maybe we could just make that up and pretend.
Okay, let's say that.
Yeah, that's from now on.
That's it.
So yeah, it's Project Oxford because some guy in Jeff.
Oh, no, Jeff. Jeff with a J.
Jeff with a J, Spielman.
Spielman,
he invented that name. Okay, but no, if you do know the name, just do let us know, please. So we're going to look at what we're going to be looking at.
Well, first of all, let's just have a look at machine learning just in general. So I'll ask you a little question now. So if you look at this this picture here, so we've got some data here. These are credit card transactions.
Yep.
And so can you, Mr. Beebe, identify what the pattern is for fraudulent transactions based on this data?
Smith, Paul, Peters. Is that
based on what you've got here? Can you figure out why those two are fraudulent compared to the other two?
There's two fraudulent ones, right?
So Paul and Peters are fraudulent, and Smith and Adams is not fraudulent.
Paul and Peter are fraudulent. There's a fraudulent column. I didn't see that. Why are they? I have no idea.
No idea. Well, based on this data set, it's because their name begins with P.
Oh, okay.
Right. So. It's not very good. That's not a great way to identify fraudulent credit card transactions.
No,
imagine if that was like we've got a friend called Pete.
Yep.
Like he's a really nice guy. Imagine if he could never use a credit card because his name was Pete and it begins with a P.
Yep.
Not good. So the data is really important. So if we take a slightly bigger data set, again, how can we identify? We've got more data to work with here. So which ones are the fraudulent ones here? We can see which ones are. So it's Paul and Peters. It's also Hanford and Edson. Those are the ones that are fraudulent transactions.
Yep.
But because we've got a bigger data set now, we can make more accurate predictions and spot patterns a bit easier. So we probably wouldn't, unless you can.
Yeah.
But before I looked at this, I wouldn't be able to find the patterns about what makes those 4 transactions bad compared to the rest of them.
Yeah, sure.
But there is a pattern. The first pattern is that The transaction is over £1,000.
Yep.
It was issued in the US. It was issued to Russia, and the person owning the card's in the 20s.
Right.
So with a bigger data set, we've got a more accurate set of patterns that even with this tiny set of data, we as humans, relatively intelligent humans, I might add.
Yeah, speak for yourself.
I was speaking about you, actually. We couldn't spot that pattern. So imagine if you've got kind of 60 million transactions and like 60 columns of data. Imagine the kind of patterns that must be in that kind of a data set. And that's what machine learning is all about, really, is it's spotting those patterns that humans would never be able to spot, to identify, and then you can build business rules based on this. So in this scenario, an app could then send a new transaction. The machine learning model would say, based on the patterns I already understand about credit cards, this one looks 70% likely to be a fraudulent transaction.
And that's the kind of cool thing about machine learning, is it doesn't come up with any kind of opinions or biases or
that's
necessarily. I guess that they could be written into machine learning
algorithms,
you could introduce them accidentally, but the idea is that it's looking at it fresh without some of those
completely
biases.
fresh, and it will spot things that humans could never spot. And the other interesting thing is it's never a yes or no with machine learning. It's a probability. So if you were to ask the question, is this transaction fraudulent or not, it would say, I'm 91% sure that is a fraudulent transaction, or I'm 20% sure, or whatever it is. So, and then it's then up to you as an app developer to kind of take that information and build in your business rules about what you want to do with that information, basically. So that's kind of machine learning. What we'll look at now as well is there's kind of a process that goes behind machine learning. So if you're building a machine learning application, you start with some data sets. So let's say that this raw data is a couple of different sets of credit card transactions. And you have a question about what you're trying to achieve with this experiment. So the question would be, how do I identify fraudulent credit card transactions? So you have the data. You then have this idea of processing the data, so making it clean, deduplicying it, kind of making sure it's a sort of consolidated, clean data set. And you kind of go through this process of data processing until you're ready and you've got what we call prepared data. So this is kind of an important point, that you can't just take raw data and then apply machine learning experiments. You have to sort of massage the data and make sure it's clean and removes any obvious flaws in the data. So that's an important process. We then have a set of machine learning algorithms that we can apply to this. So these are they're not something that Microsoft's made up, or Apple, or anybody else. They're sort of academically proven algorithms. It's maths, basically. And there's a whole set of them. And we apply those algorithms to the data to come up with what's called a model. And again, you iterate. And a data scientist would do this work. So there's this role of a data scientist, and they would understand what algorithm does what and how they can be used together. We've got some in our group that understand this stuff. And you come up with what's called a candidate model. And then once you've figured out the right model, that just becomes your chosen model. And then your application can use that model to make requests into the thing. So you go through this whole process, you come up with the model, and if this is credit card transactions, the application can say, this transaction, how likely is it to be fraudulent or not? And based on all this stuff that you've done, based on the model, the process can say, yes, it's whatever percentage it's going to be. So that's machine learning as a whole. So we have a product, Azure Machine Learning, which kind of lets you build all of this stuff in the cloud.
I've seen a couple of screens.
Seen a couple of screens of it, very good, So, and what that provides is, first it provides these pre-processing modules. So, and it's all kind of drag and drop. There's a nice interface to do this. So you can literally just drag on the data cleansing module. I don't know what they're called, but you can drag on the thing that does helps you with the pre-processing of data. We also have all of these algorithms in software format as well, so you can kind of apply an algorithm, drag and drop different algorithms onto your prepared data set and iterate through really quickly. You don't have to know necessarily how to code the algorithm, it's just there as a module you can drag on. We also have an API, so when you come up with the model, you've trained it, it actually exposes it as a REST API. So that's great, because it means whatever your application is, it can call into the live API via just a simple API call, which is good. And all of this is kind of packaged up in this thing called Azure ML Studio, which is the kind of web-based interface you used. It's like a designer interface for designing your experiment. So if you are into machine learning and you want to do this stuff, we've got some really good tools in Azure to help you do that. But the problem is really, is you still kind of need to understand this stuff. You still need to understand this process. You still need to understand these algorithms, and it's still quite complicated. So you still kind of have to be a data scientist. It makes it easier than it was before, but you still need to understand. And that's where, if you're a muggle like we are, then
I always have to stop you whenever you say the word muggle.
Really?
Yeah, because it's not obvious what that is to everyone.
It is? Surely.
It isn't, because, we've discussed this before, that like muggles, if you're not a Harry Potter fan, you wouldn't necessarily know what that is. And
but everyone's seen Harry Potter, though.
Not everyone has seen Harry Potter.
Surely.
I've not seen I have seen Harry Potter, but by accident. And it's not the like, I've checked in like events and stuff that I've been for when I've used this word. Machine learning's is for muggles too. And there's at least 2 or 3 people put their hands up. I don't know what a muggle is. Like, there's 2 or 3
people. Like, how can you not? It's like, I don't know what it's like. I can't. There's not even a comparable thing.
There is. Like, it's not everyone's cup of tea as a Harry Potter film.
Well,
but it's, for me at least, it's not my sort of. Well, it's fine, But if it's on, I'd watch it. But it's not the sort of thing that I'd go out and actively watch. And I certainly don't know that reference.
Well,
clearly. Well, I didn't know that reference till I met you, and you was like, what? You don't get this?
I don't understand how you can... Well, for the benefit of weirdos like you, that have never seen Harry Potter, a muggle is a person without magic.
Yeah, so, I know this now.
So it's kind of... So like the magic people are the data scientists that understand all this stuff, and the muggles are the you and I that don't. And we don't have that magic.
Without magic.
Yeah.
Well,
I think it's a good reference idea. I like
it is a good reference. I'm just putting it out there for the 3 or 4 people which have not seen Harry Potter, don't know what a muggle is.
Yeah, just look it up, you'll be fine.
You're in my gang.
Okay. For the rest of you, then you'll understand and appreciate that reference.
For the rest of you, which is socially like, I've got like your finger on the pulse, all about these muggles.
Yeah.
Probably Pokemon Go.
I don't know about that. We're a bit too old for that, I think.
We're too old for Harry Potter, mate.
We're too old for most things, I think, these days, aren't we?
Anyway, machine learning.
So machine learning for muggles is basically, if you don't want to do all this stuff, so this stuff's kind of, if you want to do it, there's some great tools, but if you don't want to do that, we have a set of things called cognitive services. So this is great. So this is all about, it's a set of services that kind of, we've built a load of these models and we've exposed the API for you to just call into in your app. So if we just take a look at the web page here, if you just search for Microsoft Cognitive Services.
Cognitive services.
Oh, well, there we go. It's fine though, because Bing's using cognitive services and machine learning. It's figured out what I meant. That's good. An accidental little plug there.
Snognitive services.
Snognitive services. Very good. So it's basically Microsoft.com/cognitive. And what we've got here is a whole set of APIs that are basically just machine learning experiments that Microsoft have already built based on the massive data sets that we've got available to us. That let you do useful things. So we've got one here, for example, an emotion API. And what this one does, you can upload an image and it's able to identify emotions in the image. Now, I find this one in particular very useful because I've got a 4-year-old daughter. You've got young kids as well, haven't you? So you'll appreciate this.
2 and 4.
So do you ever have this scenario? So I've got a little picture here that I'll show you. Do you ever have this scenario where you don't quite know what they're thinking? So that's my daughter Madison. And so what's going on in her head at that point in time? Like, is she happy? Is she sad? There's almost no way of knowing.
Who knows?
Who knows? But fortunately, we've got an API that we can call, and we can upload that picture, and it's going to tell us exactly what she's thinking. Okay. Now there is a bit of latency in this parenting technique, but bear with me. So
like this takes a while. Like, if you're trying to ascertain how she's
real
feeling
time,
at that point,
you can't say, hold on, Maddie, just hold that pose whilst I upload your photo to Cognitive Services API.
Well, it is an API, so you could build a real-time
You could. Well, actually, there's you can have this stuff built into glasses, and there's a good story about that done in a real-world way that actually helps people. But people that are visually impaired have there's an app that you can have on these glasses. I think they're called pivot head glasses, where you can swipe on the side and it'll take a picture and do all this stuff in real time. So there's a genuine use for it. But anyway, let's stick to
not parenting.
Not parenting, no, no, real world. But so there she is, and she's figured out. Firstly, it's good. She's got a face, so that's the first major benefit there. So
she's got a face.
She is indeed human.
Parenting tick number 1. My child has a face.
My child is a human being. And so if I zoom into the JSON results set here, it's basically giving me the bounds of the face on that image. So it's saying these are the pixels in, and you can see that it's circled that in the green there. So that's good. And then it's given me, for 8 emotions, what the score is for each of those emotions. Now, as you can see, 62% is contempt. So that's the primary emotion that this little 3-year-old is displaying in this photo. And then we've got followed up by that 20% disgust, and then just a light smattering at 9% of anger. So contempt, disgust, and anger is what's going on there. So now I know that, I can be a better parent.
Yeah, of course.
It's good. So so we've got lots of APIs here. So we've also got some websites that are built on these APIs to kind of show how they work. So I've been told before that I look a little bit like Jake Gyllenhaal.
Oh, you mentioned this.
I know, it's good. I love it. You know, I'm going to take that. It's fine, but we can prove it. You don't need to take my word for it.
Right, go for it. Let's prove it.
There's a website called Twins or Not.
Yes.
Which is built on the Face API, which you can use to check this out. So what this basically does is
do you not go to any website directly by the URL?
No, why would you do that? It's ridiculous.
I don't know. Just carry on. I just noticed this is a strange phenomenon that you don't seem to ever.
A phenomenon.
A phenomenon.
Phenomenon. So let's upload a picture of me. So there I am. Actually, no, that's the wrong picture. Let's just start this again.
Upload the same picture of you twice and go, look just like Jake Gyllenhaal.
Yeah, because I need to get the one that looks the most like. Let's upload a picture of Jake first. So I've got quite usefully, I've got a picture of Jake right here. And now let's upload a picture of me. And I haven't staged this in any way to look exactly like Jake Gyllenhaal. I'm not wearing the same shirt or jacket. I'm not looking in the same. I haven't grown stubble for 2 days just to look like it. And so let's just have a little look at what the result is here. There we go. Look, 87% is scientifically proven. You can't argue with this.
You're like a pound shop, Jake Gyllenhaal.
I know. Oh, cheers, mate.
Sorry.
That's okay. I'll take it. It's fine. I still look like you don't look 87% like Jake Gyllenhaal, so
I look nothing like him. I'm worse than the pound shop.
Yeah.
I'm like bargain basement.
I have seen photos of you that look very like Freddie Mercury actually, but we won't go there. But it doesn't stop there. There's another website which I'll just search for, called howold.net. There it is. And what this does is it uses similar kind of technology, but this assesses age. So you upload any photo, it'll tell you how old somebody is. So let's do the same thing. So let's first upload that photo of me. Now I'm 37. I was 36 when this was taken. Look at that. Bring me back down to earth a little bit there, doesn't it? I am male, so it has correctly identified me as a male, but 42. It's saying that I'm 42. So that was I was 36, so that's 6 years older than I actually was. So that's brought me down a peg or two, but let's just complete the scenario and just upload Jake again. Oops. Try another photo.
27.
And just see how now Jake Gyllenhaal is about the same age as me. He's a little bit younger, in fact. Look at that. 43.
Yeah, so he's older.
He looks older, yeah. So he looks like a lot older, so I'm happy again now. Machine learning's working in my favour now.
Yeah, it's good. I always find, I've subsequently found this is very accurate on predicting.
It is, yeah. But obviously he looks older than he is.
Yeah, exactly. Maybe it's just something to do with the stubble.
Could be the stubble, yeah.
I think so.
Maybe I'm not going to upload another photo of me because it might say that I look really old together. I feel bad about myself. But there we go. So I've built a website as well called How Happy. Now we've talked about this.
It's your website, but
it's my website.
Still search for it.
I do, yeah, and actually weirdly it doesn't even come up on search because it's not been indexed properly, so I actually have to type it in.
See, that's where it failed. So you're not getting all the new websites, which haven't Googled and don't know about.
Yeah, that's it. I'm like, it's on the dark web. How happy is on the dark web? Yeah.
Well, you need a URL. That's the dark web.
Yeah, basically. Yeah. I don't know about it. It's secret. Yeah. It's far too awesome to be on the public search engine. So I've got an interesting photo here. So let's upload this one and just see. And we'll look at how this is built in a second. But this is a Justin Bieber concert.
Oh, wow.
Now, I've picked this out especially for you because you are the Biebs.
Yes. And in America, people get the wrong impression of that. So I go over to America and say, hi, my name's
there we
the
go.
Bieb.
So you could say, if you were doing this, you could say, this is my concert.
And they think that I'm taking the mix. I'm like, oh, no, but you're British. Like,
the British BB.
Yeah, exactly. Yeah.
So anyway, so there's some interesting stuff. So what this website does is, again, it uses the emotion API, but it lets you, it sorts on emotion. So
this reminds me of a time in my life as well.
Does it? When you were on stage and you had
not that. It's that me and my flatmate once won tickets to an Avril Lavigne concert.
Really?
Yeah.
And that's what you look like.
We went along and it was just like 12-year-old girls, and me and Dave.
Dave.
We won a Capital FM, free tickets to that night to see Avril Lavigne.
Wow, it wasn't a good
awesome.
night. It was not a good experience.
No.
Well, it's funny you say that because it's not a good night for this guy.
No.
This guy,
pretty much
who I can presume is the dad. I mean, he must be.
Or security, because he's looking very.
Well, the
smart.
Security. This is a security guy here.
He's a cameraman.
Is he a cameraman? Okay, so maybe he is security.
What security man do you know wears headphones?
Well, I don't know. I've never been a security man. I wouldn't know about these things. But but the interesting thing here is like this young lady on the front, number 6. She's the least happy person at this concert. Now I presume she's a fan. Yeah. Maybe she's just overwhelmed by the occasion. So, but we can find out. Maybe she's just a bit fearful of what's going on. But let's find out. Let's search on fearful. See what I did there? And she's now all of a sudden she's the most fearful person in this picture.
Yeah.
And so you can just search and let's just have a look at this. I want to know what this dad's thinking. Let's have a look at contempt. He is he's shown the highest level of contempt for what his daughter is witnessing on stage. And let's have a look at the disgust as well. He's also shown the highest level of disgust as well. So, yeah, an interesting cross-section of society there at Justin Bieber concert. And you can go to How Happy and you can put your own photos on there. Cool. So what I thought we'd do is we'd have a little look at how that's actually built, do something useful rather than just play these silly websites for the rest of the show. Yeah. So I've got Visual Studio here. I've got an ASP.NET Core web application.
Sure.
And what I'm going to do is I've got some snippets that we're basically going to build that How Happy website, or a really light version of that How Happy website, just to see how it hangs together. So first thing I'm going to do is I'm going to go into my index. So this is just the standard template. I've done File New Project. I did it before we started. I'm just going to get rid of all of that. Don't do that. Get rid of all of that. We don't need any of that. And I've got some snippets there. So all this does is just some basic
inline CSS there.
Yeah, well, I've started using snippets, which is a professional thing to do. So I thought I can't be too professional. I'll dilute that by some inline CSS because I know that you would have.
I love a little bit of inline CSS. Yeah. It's the way I roll.
It is the way I roll.
Since 1999.
Yeah, there's nothing wrong with it. Actually, Google recommend it now.
Yeah.
On the homepage for performance, they recommend that above the fold content, some of it should be inline. That's actually so. I'm actually with the very latest. In recommendations.
It's good, yeah. It's good when that happens.
Yeah. So this is just
do you use that excuse for every bad performance technique?
Yeah, exactly, yeah.
Google actually recommends
it. Yeah.
So searching for, not using URL, it's actually Google recommends
because you're getting served adverts. So that's why.
Let's make this political.
No, we've done that with the iPhone stuff. We're way past that, yeah. Right, so this is very simple. It's just a form. I'm using the new ASP.NET Smart Tag, tag helpers. Smart Tag's an Office thing, ignore that. But it's just a form. So all this form does is it submits into what's going to be the MVC control that I'm going to create in a second. But very simple, nothing to it. Okay, so the next thing I need to do is create some JavaScript, which I'm going to do here. I'm going to just go to site.js. I'm going to replace this with yet another snippet. So don't worry too much about what this does, but basically this has the job of posting to the MVC controller, getting the JSON back from the MVC controller, and it does that stuff about painting it on the screen and painting those boxes and doing all that kind of stuff. So we don't need to, this is all on GitHub. You can look this up if at the end you think this is the world's best application, you really want to find out how it's built, you can go and do that. But we've got some JavaScript there. So what I'm going to do now is go into my controller and add a few bits here. So I'm going to do this snippet here, which is just basically setting up a result action. So this is the thing that the JavaScript calls into, and this is the bit that's going to do the work of going off to cognitive services, sending the image, all that kind of stuff. We've got some code here that will get the file that's submitted from the form, so we use that file picker. And so that's what gets the file into this file object here. We're going to add some more code to this now. So this line of code, that I'll just resolve all of my oh, I've missed a step. Hold on a second. Sorry. Before I do that, I need to add the model. So let's do that quickly. Add a new folder called models. And I'm going to add a face model. So this is useful because it's going to basically, when I get my JSON back from the Cognitive Services API, I need to sort of cast that to a .NET object. So let's just create that .NET object. Delete that. Oops. There we go. So this is basically contains a face rectangle object which has the bounds of the rectangle, so the height, the left to the top and width, and it also contains a set of scores as well, so the numbers. So that's basically what comes back from the Cognitive Services API, and I'm going to use that to, in my controller, I can now resolve this to get a list of faces basically.
Right. Okay.
I'm going to resolve all of this stuff as well, and I'll
just
talk
made
through
it that JSON. You just said it.
I'm making
it strongly typed.
Yeah, basically, yeah. So this should look quite familiar. So this is really simple HTTP client. If you've ever done any C# code, you've probably written this code before. And the point of showing you this is that it is just a simple API call. There's nothing special to it. So we've got my super secret API key that if I just scroll just slightly off screen there, you won't be able to see the whole key. Ignoring the fact that
2-3 numbers.
But you've got the endpoint, and then you set up a new request. The only slightly special thing is that you have to add this subscription key, which is where you put your API key in there.
Yeah.
I'm going to stream the content of my file up to the API. I do a post. It's going to stream the JSON back. So this is going to represent a set of JSON back from Cognitive Services, basically.
Yeah.
So next step is I'm just going to do. I'm basically going to cast that JSON using JSON.net.
Yep.
I just need to convert that one as well into a list of faces, and then I'm going to order the faces by default, order it by happiness.
Okay.
And then I'm going to return that back to my JavaScript, so it's JSON.
Okay.
So that's it. That's the whole application.
Did you need a snippet for that last one?
No, but
you didn't.
I didn't. But I was into my snippets mode then, so I thought I may as well carry on with the snippets. But no, I didn't strictly need that. And so let's just run this, and if all is well, we should have a little version of that How Happy website, which works in a good way. So, and again, this is all on GitHub. You can get the code for this quite easily if you're that impressed by it, which most people aren't. So
you've tried it 100 times. No one likes it. Here
we go. So this is our little ASP form. Let's get that same photo. There it is. Says our Justin Bieber concert. We're going to upload that. So the JavaScript's uploading it to my controller. That's going to Cognitive Services. It's bringing the JSON back. I'm posting that back to my JavaScript. And it's painting all of the pictures on the screen there. So simple. We can't. It's only happiness in this one. We can't change the different things. But that's just a simple example. The point of showing you that is that it's just an API call. That's all it is.
Well, almost all of these machine learning APIs ultimately end up with just an API. Even the ones that you create yourself, the machine learning studio, it just ends up being a RESTful API, which you then send some data to, whether that be video, image, text, or whatever data it is. And it's kind of saying all the things you know about the model. Tell me about this piece.
All the parameters.
Data. So. The emotion ones is one of the easiest to kind of use. Well, actually, the text ones that you
because
you don't have to.
It's sometimes tricky for figuring out. Half the challenge is figuring out how to, like this one, you've got to stream an image to the API, which isn't something you necessarily do all the time. So if you've not done that before, that can sometimes take a little while to figure out.
I searched the internet the first time I went.
Did you?
I landed
Did you use
a blog.
Did you? There we go.
Did,
Oh, well, that's useful to know.
Yeah, good. And then
so that's not on the dark web then. My blog's obviously not on the dark web.
I love this concept like that. Imagine it, you could probably convince someone that's what the dark web was.
Yeah. Do you say anything with
dark web? It just means it's not on Google.
Yeah. If you say anything with enough confidence, people believe it. I've learned that. This is my main trick.
It's only the stuff which is served up by Ask Jeeves. That's the dark web. Okay, cool.
There we go. So that was all I wanted to show you, basically. So we've got the kind of basic machine learning stuff, this idea of it's all about data. The more data you've got, the more patterns there are to potentially spot in that data. Machine learning is going to spot patterns that humans never will. That's just the benefit of it, really. We've got the Azure Machine Learning Service to kind of, if you want to use your own data and you want to actually set up your own experiments, that's a really good way to do that. You don't have to have local processing power or your own servers. It's all done in the cloud. And if you just want to use the benefits of machine learning and not necessarily worry about how it works, that's where cognitive comes into it. And there's actually, I think there's 59 distinct functions across all of the cognitive services. So there's a ton of stuff you can do.
They can do all sorts of things.
Yeah, it's crazy things.
One of the things I've been doing recently with so if you go to captionbot.ai.
Okay. Can I search for it or do I have to? Oh gosh, really?
You Captionbot,
See, it works every time, it's fine. Just search for it.
Search for it, Okay, and then upload any picture.
Really? Can I choose any picture?
Use that picture.
Can I do that? I want to use the Justin Bieber picture.
Do it, yeah. See what it says.
Oh no, that's not.
Analyse that picture.
Okay.
So it says, I think it's a baseball player holding a bat on a field. Right. Which is accurate.
Yeah.
So go back to the main page. Go to the.
I just press back.
Yeah.
Sorry, I'm so bad at using the internet.
Have you seen a browser before?
It's actually. I need a URL by that.
No, you don't. It's just that you've scrolled over to this side of it. What's going on? This one.
Oh, okay.
Upload a photo.
Yeah, you actually teach me how to use the internet here.
So this is called a file dialog, right?
Yeah.
So where's that picture of Justin Bieber? Yeah.
That one, yeah.
You can take over from this mouse anytime you want. There you go.
No, you did a great job.
Right, there you go.
So
analysing image, it says at the top.
Okay.
I think it's a group of people posing for a picture, and they seem, and then it does the emotions.
Oh, that's cool. Well. So it's actually picked up. So that data will correlate with what we showed in.
Yeah, because it doesn't just do. If you look at go back to the Microsoft.
So this is a much better version of how happy.
Well, it sort of is. Although it doesn't. It's you're not got bounding faces and stuff like that. They've not actually picked out which ones are happy. And so if you go to the Microsoft Cognitive Services thing and go to the APIs and look at the computer vision one, not the emotion. Yeah. They're using a combination of the emotion one and computer vision. Yeah. Because computer vision, what that one gives you is it looks at an image and then it responds, as you can see here in JSON.
A man swimming in a pool. So let's upload the. Let's try that same image here and just see the actual data that gets used, and we'll see how that's actually been put together. So a group of people posing for a picture,
and then what they've done is they've then subsequently gone, okay, let's go and check for. The actual demo's got a lot more onto it as well. They've got a face thing, they've got the age which they reckon people are. Yeah. So it's combining the emotions, the age, the face API to get lots of different sort of data about it. What I quite like about that is if we can see the confidence level here, is it's 0.6. So actually a group of people posing for a picture, it's actually 60% confident of that.
Right, and that's back to that percentage thing. It's not it's not a binary thing, it's a likelihood.
Yeah, precisely. And what you find is that the captionbot.ai, when it's below 50%, they start saying, I'm really not sure, but I think it's this. And that's a really nice little touch to add to your application when you know it's a low confidence, actually telling them that.
Yeah, that's really cool.
Some of that stuff, the emotion stuff, is
highly intelligent emotion stuff.
It's really clever that it can do it and understanding stuff from pictures and things. But I've been using some of there's two features inside of Cognitive which are really, I think if you're a web developer, quite useful. One is recommendations. Right. Yeah. So like building a recommendations engine or something like that.
Like people that purchase this also purchase this.
Yeah, like an Amazon sort of style recommendation engine. We have a whole service where you can upload like your catalog of products, and then you can build recommendation. And if you pass around sales data and stuff like that, and it creates a whole recommendations engine for you. So then you can provide it with a product, and it will say these people who bought this.
That's pretty cool. Yeah, that's like almost every website that's any sort of e-commerce.
Yeah, precisely. So when my old job was in e-commerce, I was like, I could absolutely use that one. So. Although, because you have to supply your own data to it, it's not the easiest one to just get started with nothing. And I currently don't work in an e-commerce company anymore, so it was not the easiest one. So I started looking at this Lewis stuff, or specifically language understanding. Yeah. So we just switched to my computer. Okay, sure. A little slide deck which kind of explains a little bit about.
Slides. It's very professional. Well, you can tell that you've taken over now. There's an air of professionality now that wasn't.
Professionality.
Yeah. Is that a word? I don't know.
No, I don't think it is. But you made that.
But you know what I mean, though.
Professionalism, I think. Is
that's
what you're
the one.
For.
Yeah. But that doesn't illustrate the point? Right there.
Quite good.
Yeah.
But I was speaking at a conference last week. Reasons 2, and. I gave a talk, and part of this talk showed about this little Lewis thing that I was building, or the language understanding. Yeah. And it's trying to get the intent of what a user is asking you. And this is particularly useful if you're building all sorts of things, but specifically if you're building around speech. Right. So if you're building, maybe if you're building a bot, right, which you actually want to talk to. Yeah. Then getting the intent of what that user's asking for is really tricky. Yeah. Like, because a human will ask the same question in lots of different ways.
Yeah, I mean, that's kind of the whole thing behind bots, really, isn't it? It's having that kind of natural language conversation.
It's what we need to get to. And Lewis is a good way, this language understanding service is quite a good way of getting to it really quickly. I picked this up and I've only been working on it a couple of hours and I've built something which seems to work. Right, so, which I'm pretty happy with.
Pretty impressive.
Yeah, so if we go to the slides, there's 2 questions here. Yeah. So Reasons 2 is a conference in Brighton. Yeah. What I did want to do is build a bot which was intelligent enough to tell me like a voice-activated agenda, effectively.
Yeah. Okay.
So these are the two questions that I hypothetically came up with. I'd like the bot to be able to answer, or the to be able to understand.
Like a conference bot.
Yeah, which is who is the second speaker on today in the Dome? And the
Dome is one of the rooms.
Yeah, sure. That's like there's 3 theatres at this conference.
Because there's a nightclub in Birmingham. There used to be a nightclub in Birmingham called the Dome, and that has a very different memory to what we're talking about here.
So the Dome, the Studio, and the Dome Studio and the Corn, they're called the three sort of theatres there. And the Dome was where I was speaking, and it was like, well, who was the second speaker on today in the Dome?
Yeah.
And then the second question, what is Martin Beebe speaking about tomorrow?
Okay.
And that was kind of what I started at. It's like, wouldn't it be cool if a bot textually could answer this and say something?
Is that a word?
Textually, like maybe I've just made it up. Maybe I don't know.
I kind of think with words, like if somebody understands, then it must be a word.
Yeah, and if someone doesn't point it out, like you can get away with it, style it out.
So okay.
In text, like in a Skype conversation, these could be asked. But then also, if it was in speech or was using speech, there are APIs which can convert speech to text.
Yeah.
So for the demo, I was thinking, well, that's a good idea. It's like you have, we use the speech API to do.
Yeah, which is the cognitive API as well.
Precisely, yeah. So you can get this whole end-to-end experience of like me giving a command to a website, the website listening for the speech recognition, converting that into text, passing the text over to the language understanding service, getting understanding out of it, and then using that to then go and search an API.
Sounds awesome.
So let's convert these two questions
let's go for
into break them down a little bit. And this is what I want Lewis to be able to do.
Okay.
One is to try to understand the intent of the question.
Yeah.
So my application has a few different functions in it. The API has a function which works out who is the speaker.
Right.
So given various different parameters, it will figure out who the speaker is.
Yeah.
So you can say, who is the speaker, second on today.
Yeah.
So the intent for that first question is who is. I want it to go to the who is function.
Yeah.
The second question is what is, like what's the subject matter.
Okay, yeah.
So I've got two distinct questions, or two distinct functions to answer these two questions.
Sure, okay.
So imagine I go away and I build that in my application. Now my application has two functions in there.
Yeah.
So I need to figure out which function I'm going to call based upon one of those questions.
Sure, okay.
So that's what we call the intent.
Right.
And so in a Lewis application, when you're creating a Lewis application, intent's really important. So I wanted to be able to pick out of that question, however I said it. So if I said, who is the second speaker on today in the Dome, that's the thing. But I could say something really broken English, like people do search or say things strangely to computers. So they might say, second speaker today.
Yeah. They might talk to it like it's a computer.
Yeah. Who is?
Yeah.
Like,
or if Yoda ever got involved, that would be a bit weird as well, wouldn't it? Like with all these strange way that he speaks. Yeah.
And
because he is real.
I want to. I want it to be able to, from however that question's been asked, for it to understand the intent. Okay. Not just in this really defined way, but very loosely understand.
Natural language interaction.
Yeah, exactly. I want to be able to ask that question in many different ways. And then the second question, what is speaking about? They're the intent of that question. Yeah. And that's what I want it to be sort of looking for, I guess.
Okay.
And then there's entities in those questions as well, which is, this isn't what the person's asking, but this is extra pieces of information. So on the first one, it's the second on today in the Dome. Right. And in so second being an ordinal, like first, second, third, or whatever. Yeah. Today being a date. Yeah. It needs to recognise today is not only, that means a date, and then also convert it into a date for me. Sure. What does today mean in reference to when I'm asking the question? And the Dome, I need to recognise that as a theatre, even though it doesn't know what a theatre is. Yeah. I also need Lewis to understand, on the second question, Martin Beebe's a person, because then I can search for that speaker. And I need to know that tomorrow is also
another day. Yeah. Okay. Cool.
So what I want it to be able to do is basically map this thing for me. From the first question, give me the function who is, the ordinal second, the date, the 7th of September 2016, which is when this particular event took place, the theatre's the Dome, and then the second question, what is the person, Martin Beebe, and the date? And I want it to provide all that information for me from whatever I'm going to ask it or utter to that.
Just before we go on there, you've missed the closing bracket there on that slide.
Well, luckily,
the professionalism is just, you've been docked a few points there. I'm afraid. Sorry about that.
Well, I'm lucky that I don't actually have to compile my slides.
You don't care anyway.
So here we are inside of Lewis. So the URL for this is...
so it stands for Language Understanding Intelligence Service, doesn't it? That's what Lewis stands for.
Yeah.
It does,
Well, there you go. And then .ai, artificial intelligence, I guess. And then you've got and you go in there and you click on the application. I created this application, and the first thing I did was give it those intents. So this is like, the way you might view it in other ways, but I view this as mapping onto functions inside of my application.
Yeah, okay.
So I've got a couple. When is that taking, who is, and what is.
Okay.
So there's 3 different things, and then also there's an intent of none.
It's like a catch-all sort of thing, yeah.
And then I've added some entities.
Right.
Like in my application, the dome is an entity, it's a theatre.
Yeah, sure.
So I want that to just be captured and it to recognise it as a theatre there called the dome inside my question. And then name as in a person's name. I know all the speakers ahead of time.
Yeah.
So there's an advantage of that. Like
sure.
What I found though is that Lewis is quite good at this thing. I've put name in there and teach a few bits.
Taught it.
What am I talking about? I can't speak English.
I'm having a bad influence on you.
I know, this is terrible.
Sorry about that.
But name is, I found that it's able to, after a bit of a few utterances, which we'll talk about later, it's able to pick up what are names and what are not names. I don't actually have to give it distinct names.
Give it some examples and it figures the rest out.
Somehow, magic.
Machine learning.
Got some pre-built entities. Ordinal, second, third, first. That's a pre-built entity. It will recognise that.
I see. So it's like pre-trained to
recognise those. Date and time, and there's a few others as well in here. So you've got number, temperature, dimension, money, age, geography. So you can say places. Encyclopedia. So certain important names and stuff like that, and percentages. It can recognise those in sentences already. And then what you do is you ask it questions. So, who is the second speaker in the dome today? And what it does is it says, okay, this is mapping onto that function, who is. And I've reckoned the ordinal. I've reckoned that's a theatre, and I reckon that's today. So it's done a really good job of that. And I can just submit that.
So an utterance is a way of you're effectively training the model here, aren't you?
Yeah.
Sort of saying
second, tomorrow, who is speaking?
So that's how Yoda would say it.
Yeah, exactly. And it's picked up some of it. Ordinal, tomorrow. I didn't put the dome in there actually, but it's who is speaking.
So you could say the dome at. That's how Yoda would say it.
Oh, would he?
Yeah.
Right, so the dome at second speaking
tomorrow. Who is? I can you're saying it like that.
It's done all right. It doesn't actually really recognise the dome there, but I've only trained this about a few utterances. It's not that, I think if you look at the side here, I
love that word, by the way.
Utterances.
An utterance,
18, 7, and 3. So there's only like 30. Why can't I even add up now? What's going on?
Know.
About 30-ish.
Yeah, well, let's just imagine that's right.
But it is getting the who is part of it, right, at least, and stuff. And so you train it with utterances, and then you get to say, okay, that dome, actually, that was a theatre.
Right.
Submit that.
So you can fill in the gaps.
And then it can retrain itself on the API. What you're then able to do is...
So this is an important point there, the train button there, you have to remember to press that.
No, weirdly, it doesn't do it after everyone, but if you put a few utterances
it just does it,
But you can see I've done like 27 utterances, and it's figuring stuff out. It's starting to work, and obviously the more you put in and the more use cases. But obviously you're not going to think about every way that someone's going to be using your API. But what you can do is you can publish this API. So there's the API. You can query it. So you can say, who is the second speaker on today in the dome?
Okay.
And it will create a URL. Click that URL. And this is the response you get from
it.
So in your application, really, all you need to do is call this. All it is just a URL with your with the URL encoded, the question. And then it comes back with this. And it says, there's the query. The intent, we think who is the intent. It's giving it a really definitive, this is definitely who is question. It gives you all of the other functions in your application and gives you a question of whether or not it thinks it is. And it clearly thinks it's the who is.
So this is back to that thing we talked about earlier in terms of in the world of machine learning, it's all about a score, a likelihood. It's not necessarily, apart from the Lewis thing, it's how likely is this thing to map onto that particular entity.
And then it gives you a list of the entities, and it's got the second and today as well built in there. So as people are calling your service, and really maybe using this application in real life, you can go onto the review things, and it will show you what people have asked.
Okay, cool.
And you can train it based upon the real world.
So it gets better over time.
Absolutely, yeah. So you can constantly retrain this, constantly tell it what it should have picked. Oh, actually, that's a false positive and negative. Yeah. And very, very quickly, you're getting a URL built which understands natural language around your specific domain problem, but magically, and it's quite amazing. This literally is like an hour's worth. It
is amazing. This is one of those, like, you don't get this very often, but occasionally you get tech moments where you're like, wow, that is amazing technology, and like that is totally one of those moments.
It's incredible the way that it solves these problems, and there's so many things that I've had this problem before in my own company, where this would have been amazing. Also, there's another little service they do, not Lewis, but another one where if you concatenate words together, and provide the whole concatenated string, like it will find where it thinks the spaces should be.
Right.
Like, I've had that problem.
Yeah.
Massive, like with the German language in particular. When you're doing search on e-commerce websites, German people concatenate all the words together and then search on that one concatenation. Yeah. It's really hard writing a search engine in German. That would have been amazing to be able to use that language model, because it can split up, and it's useful for like hashtags. Split up a hashtag into meaningful the words.
Right. That is cool. Yeah.
So anyway, that's Lewis for you, and that's how you could go and help. It could help you build, say, conversational bots.
Yeah.
You could augment a search engine in your application.
So this is an important point as well. So I think a lot of people that haven't necessarily looked into Lewis might assume it's just for bots, but that's absolutely not the case, is it?
I think it's probably it's any time that you need to understand someone's intent from free-form English, and that's quite a powerful thing that you can add. If you want to add speech recognition to an application, if you want it to find voice commands, anything like that, this could really help with.
And also, it's just an API. So
just an API REST.
Whatever language, language you want to build it in.
Yeah, once that model is built, you can call it from anything, really. So it's pretty cool.
Awesome.
Go take a look.
Love it. I will do.
Yeah, cool. Well, that's it for our Tech Day special.
Yeah.
Thanks for joining us, and get back to the regular content now.
Yeah.
We'll see you all another time. Hopefully, we'll be back with a Web Hack Wednesday every Wednesday on Channel 9. Probably in a couple of.
Signed us up to that now by saying that.
In a month or so, we're going to be back. All right. We'll see you then.